Hey everybody, this is Larry. This is day 29 of the June Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about today's poem. And yeah, um, today, I ran, I ran about 4 miles and then added about like 12 more miles after that, not consecutive. There's a lot of running today, so I'm really tired. This is really late. I slept in, got a good amount of rest, hopefully, maybe, and now I am ready to finally do lead code. Uh, you know, yeah, let's go. That's it. I'm tired still, but let's get started. We're at 1498. Number of subsequences that satisfy the given sum condition. You're given an array of integer nums and an integer target. Return the number of non-empty subsequence nums such that the sum of the minimum and the maximum elements on it is less or equal to target, since the sum of the min and the max element on it is less than or equal to target. Since the answer may be too large, returns this mod. Okay. I mean, once again, this is subsequence, so we have to think about, the theme that we've been saying all week, last couple of days anyway. I don't know how long it's been, which is that does the order matter? Maybe you could say that in this problem or in general, subsequences order doesn't matter. And I don't know if I would actually go that far. They do give you, remember, these problems are selected for you in a given way, so you may skew that way and you may have a false positive in the future. But it is something to think about in general, just like, okay, well, I have this problem where the subsequence or subarray doesn't matter. Does ordering matter, right? And in this one, I guess not, right? What does it mean? So I was going to look at n, and if there's an n square number, then that would be fine. Target is less than or equal to. Now, I for some reason I read equal to target only, or like I know I read it out loud, but I paused it to only target. So I was like, huh. I look at an example. That 3 doesn't add to 10. So okay. So yeah, so I think the idea is that, well, how many subsequence can there be? Well, first thing we want to do is we just sort, right? The first thing that we always said is that does ordering matter? Well, if it doesn't, let's sort and see what happens. And here, then it gives us a really easy min-max type thing, right? If the min, and there are probably a couple of ways you can think about this one, but I think for me, now, let's do a naive or more naive solution, right? Which is that for, and what I mean by that is just let's try n square. Now we know that n square is not going to work because n is 10 to the 5th and n square will be 10 to the 10, which is going to be too slow, but we can write it out, right? So we have right? I plus 1 n, or maybe even I actually. And maybe we can we think about this as num sub I is min, num sub j is max, right? Okay. Oops. And what does this mean? This means that now, let's say we have total is equal to 0, and of course then we return total mod mod. Okay, so then now if num sub I plus num sub j is less than or equal to target, then how many numbers do we have? Well, well, I is min, or num sub I is min, num sub j is max. That means that the number of subsequence is just the number of elements inside, right? Because for example, well, not precisely that, but it's a function of that is what I mean to say. Because you can see something like, or even just this one, right? Let's say or num sub I is equal to 3, num sub j is equal to 6 because we do the for loop. Then that means, let's actually add a couple more numbers here, right? Maybe something like that. Well, now there are 4 numbers in between. Well, what does that mean? Well, for every one of those number, for every one of those numbers, they could either be on and off, right? Because it doesn't matter, or it doesn't, not that it doesn't matter, but it doesn't change the condition, right? The sum condition that's outlined in this problem. And if there are 4 numbers in between, then, and each one could be on and off, or selected or not selected, then it's 2 to the 4, right? In this one. And that's it, right? So that maybe you can write something like total power of j to the, or j minus I, or sorry, I minus j minus 1, right? No. I'm trying to index off by ones are always tricky for me, so I'm trying to think. For example, here this is 0, this is 2, so then that means that there's 1 number left, right, inside. So actually, it's just j. Oh no, this is right? But the reason why I'm hesitating is because if j is equal to I, then this is -1, which is very awkward. Because it should be 0, right? Or ideally we want this to be 0. But maybe we just add an if statement. Maybe that's a little bit confusing. I think this is fine, right? So maybe something like if j minus I minus 1 is greater than or equal to 0, then this is the case. Because you have 0 and 1, then you have 2 to the 0. Else that means that I is equal, this is case, and then we just add 1, right? Because there's one subsequence in which this is true. And then that's it, right? I think, hopefully. Let's give it a spin. I mean, obviously this is too slow, but we still want to verify our ideas for correctness, given the examples anyway. Okay, so this looks good. That means that now, at the very least, I'm more confident. Is it 100% confident? Probably not, but you know, at least more confidence, right? And yeah, and then now we have to convert this. How do we convert this? Well, or how do we optimize for this? How do we make it faster? Well, yeah. Notice that we have this condition. We have to loop one of them just because that's how it works. But let's say we want to optimize away one of the loops, the J loop, right? Then how do we do it this way? Well, we can binary search nums for this condition, right? Meaning that right now we have num sub I plus num sub j is less than or equal to target. And then now we subtract num sub I on both sides, so num sub j is less than or equal to target minus num sub I, right? And of course, both of these are known, right? One is the input, the other is what we're looping on. So then we just want num sub, we can binary search this number in the array. And that's it, right? You do have to be a little bit careful, of course, but yeah. So so we have bisect left of nums. Is it bisect left? I don't know. I always write it out afterwards, right? Because basically we want the index in which, yeah, so actually this is bisect right. And bisect right just means that if it's equal to, what do? Well, we want to go to the right of it. And the reason is so that now everything to the left of it is fine, right? So this is going to be the index. So this is j, right? If j is less than, or if I is greater than j, then we just skip. And actually, I think we can break, because that means that in the future this is always going to be true, because this is always sorting up, right? So yeah, so we can break. Otherwise, then we can just do this. Now we already did this, kind of. It's not quite right yet. Why isn't it not quite right? Because if you go back to it, we just found the j. What we didn't do is, right? Let's say we have something like this. What we did is that, let's say for target is equal to 12, right? For the num sub I is equal to 2. if num sub I is equal to 2, then num sub j is going to be 7, right? But this formula doesn't work because this formula, all it does is just counts the middle. What we actually want to do is count the sum of all these numbers, right? Because it's 2 to the 3, or sorry, the subsequence containing 2 and 3, 2 and this second 3, 2 and 4, 2 and 6, and 2 and 7, right? And then now you just have to try to figure out how to add, how many combinations are there. And it turns out that actually it's pretty simple, because if you sum it all up, this is going to be, well, just 1, this is 2 to the 1, this is 2 to the 2, this is 2 to the 3, this is 2 to the 4, and then just one number by itself. So this actually all sums up to 2 to the 5th, right? Meaning that it is, yeah, just sum it up. And there's a, and you can write it out, I think. If you write it out, maybe that's a little bit easier, right? Because maybe I'll write it out for you, right? This is, even though this is late, maybe I'm tired, right? This is one possibility. Well, actually, technically 2 by itself is one possibility, right? 2 the second 3 is 2 possibilities because you could skip or keep this 3. 2 4 is 4, 2 6 is 8, 2 7 is 16, and if you sum it all up, it's gonna be 32, which is 2 to the 5th, right? And of course, that's one way of thinking about it. You can also just think about it as none of these numbers matter as the max, or only up to here. So that means that you have 5 numbers. You can choose on and off for either of the 5, and that's gonna be 2 to the 5th. And so now we can say it is actually just j sub I power of this, and and that should be good, right? Mostly. Oh, am I off by 1? 2 I. Oh yeah. Am I off by 1? I mean, maybe bisect right is wrong. Is it bisect right if it's equal to? So if it's 3, we search for 6. We found 6, so we go to 7. Oh, that's why, because we went to 7 instead of keeping the max. Okay, so that means that this is going to be j to get to the last number in which it is bigger than. Whoops. All right, looks okay. This is still a little bit problematic because you can imagine that for 10 to the 5th, this goes, you know, way too big. So all you have to do is just change it to a mod pal. You could even pre-calculate it if you like, and then that should be good, hopefully. Yeah. Because of this mod pal, it actually reduces the complexity a lot. But you can also just look at this as O of n, O of log n, and n log n anyway here. So total is going to be n log n, and that's it. That's all I have for this one. Let me know what you think. Thanks for watching. And yeah, stay good, stay healthy to get mental health. I'll see y'all later and take care. Bye bye.